on section 7.3 with a couple more examples. Okay, we're is still in linear land here. We only have an x term, not an x squared. And we're going to solve the absolute value of 5x plus 1 plus 7 is equal to 3. So first of all, we take the case that what's inside the absolute value sign, that is actually positive. So we leave it as is. We're solving 5x plus 1 plus 7 is equal to 3. 5x plus 8 is equal to 3. 5x is equal to negative 5. X equals negative 1. Okay, let's check if that makes sense. Just 5 times negative 1 plus 1, absolute value, plus 7 equal 3. Just negative 5 plus 1 plus 7 equal 3. Well, the absolute value of negative 4 plus 7 equals 3. Does 4 plus 7 equal 3? No. Reject. Okay, so that's the first case. The second case is we're assuming what's in the absolute value signs is actually negative, because that would spit out a positive, okay? So we're solving this equation. We distribute that negative. Oops, that already was a plus 1, so that becomes a negative 1. That's my error. We'll bring the 5x to this side to make it positive. So we have negative 1 plus 7 minus 3. Okay, so that would be 6 minus 3, which is 3. So in this case, x would be 3/5. So we need to check that as well. Does 5 times 3/5 plus 1 plus 7 equal 3? This just becomes 3 plus 1. The absolute value of 4 is going to be 4. That does not equal. Reject. Okay, right from the get-go, we should have had some intuition here, though. What this says is a positive number, because remember, an absolute value is always a positive number. A positive number added to 7 equals 3? Not even possible. Okay, now we're doing quadratics. So we know it's a quadratic because there's a squared term. That tells us that we're doing quadratics. And what we have to do is we have to spend a second and remember the definition of absolute value. Okay, so we could write the absolute value of x squared minus 6x means that it's just the same as x squared minus 6x whenever it's greater than or equal to 0. So when is x squared minus 6x greater than or equal to 0? Well, what I do is I quickly solve it over here. I have x times x minus 6. When is this greater than or equal to 0? Well, whenever x is greater than or equal to 0, or 6 is greater than or equal to 0. Sorry, whenever x is less than or equal to 0. Why would it be less than or equal to 0? Okay, let's think about this for a second. If we put a negative 1 in here, if we had a negative 1 right there, then this would also be a negative, so we would get a positive value. So this one is a little tricky to figure out, okay? So whenever that happens, the other way, actually probably the easiest way to do this, is I would quickly graph x squared minus 6x. I would graph it here, x squared minus 6x. Get rid of whatever junk I was doing here. Okay, y is equal to x squared. What was it, minus 6x? Okay, I would graph that. I would spend a second and zoom in here. And I would see that that happens, this graph is always above the x-axis whenever it's less than 0 and whenever it's greater than 6. This is probably an easier way than the way I just showed, is quickly putting it into my graphing calculator. Okay? So I know that this graph is positive whenever x is less than 0 and whenever x is greater than or equal to 6. The absolute value graph now is negative of x squared minus 6x. That's when I reflect it. So if I quickly go back to my graph, the part of the graph that would be reflected is this part right here, this whole negative area, right? That doesn't make sense. If it was absolute value, it'd come up. I wonder if I can just write absolute here. No, it doesn't let me do that. I think it's function keys on here. Anyways, oh, it did let me do it. Sorry. See, that's the part that gets flipped. Um, and that happens between 6 and 0. And remember, I always forget how to do this, so I just write 0 and 6, put x in the middle. Well, I say x is less than or equal to 6 and greater than or equal to 0 between those areas. Okay, so what we have to do is we have to actually look at these two cases to solve this equation. So we're going to call this case number 1 and this case number 2. Okay, so case number 1 is x squared minus 6x is equal to 8. Solving for 0. Okay. Are there two numbers that multiply to be negative 8 and add to be negative 6? Not any that I can think of, so I'm going to quadratic formula this, okay? X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Subbing in values, b is negative 6. So negative 6 is positive 6 plus or minus the square root of 36 minus 4 times 1 times negative 8. So that's going to be 4 times 8 is 32 all over 2 times 1. Okay, so I'm going to get 6 plus or minus square root of 68 over 2. Oh dear. 16? 68 is 16 times something, I believe. Let's look at 68 on my calculator here. 68 divided by 16. No, I was wrong. 68 divided by 4 is 17 times 4. Okay. So I can write this as 6 plus or minus 2 root 17 over 2, which could be simplified to be 3 plus or minus the square root of 17 because I reduced. Okay, so there's my first answer. And now what we really should do is we should verify this back in the original equation. Okay, does the absolute value of 3 plus or minus the square root of 17 all squared minus 6 times 3. Let's just do the plus one first, actually. 3 plus root 17. Does that equal 8? Okay, let's square this. We get 9 plus 6 root 17 plus 17 minus 6 times 3 is 18 minus 6 root 17. Look at that. Those root 17s cancel out. Pretty cool. Does that equal 8? Does 9 plus 17 minus 18 equal 8? You better believe it does. Okay, so that one works. Sorry, this was supposed to be all absolute valued, but because it was all positive, it worked out to be okay. Okay, now let's verify the other one. 3 minus root 17 all squared. What am I doing here? Minus 6x. Oh, this was supposed to be all absolute valued. So I was supposed to take the absolute value of all of that. That was my mistake. Okay. Minus 6 times 3 minus root 17 because it was, remember, it was x squared minus 6x is the absolute value of that equal 8. Okay, this would be 9 minus 6 root 17 plus root 17 minus 18 plus 6 root 17 equals 8. Well, I have 6 root 17 and negative 6 root 17. Sorry, root 17 squared should be 17 here. Okay, so then I have 9 plus 17 minus 18. I get the absolute value of 8. Does that equal 8? Yes. So both of these solutions are correct. Okay, but that was just case 1. Now we have to look at case 2. And don't worry, case 2 is easier. Okay, case 2 was if we had negative x squared minus 6x is equal to 8. Okay, using that piecewise. Let's look at this. This is negative x squared plus 6x is equal to 8. Solving for 0, I'm going to bring everything to this side. So I have a positive x squared term minus 6x plus 8. Two numbers that multiply to be positive 8 and add to be negative 6. So in this case, x equals 4 and x equals 2. Subbing back into the original equation, remember which was x squared minus 6x, absolute value equals 8. Putting 4 in, we get 16 minus 24 equals 8. So we have the absolute value of negative 8 equals 8. Yep, so that one's right. And let's quickly put 2 in. So we get 4 squared minus 12. Does that equal 8? Well, 16 minus 12. I did something wrong. 2 times 2 is 4. 6 times 2 is 12. 2 times 2 is 4, not 4 squared. That's what I did wrong. Okay. Is 4 minus 8 is negative 8. 4 minus 12, rather. The absolute value of negative 8 is 8. So both of those worked. Okay, just to recap, that was a long example. First thing is we had to split it up into two cases. First of all, this case where it's just a normal equation, and this was from our x-intercepts. And then we did the negative of the equation whenever it's between those x-intercepts, whenever we have to reflect. Okay, we did those two cases, we got solutions, and we substituted them back in. Okay, one more example, solving an absolute value equation involving both linear and quadratic. Okay. So what we have to do here is we have to look again at this quadratic, and we have to look at the two cases. So when we have x squared minus 1, when we graph x squared minus 1, let's look at where those intercepts are. X squared minus 1. They should be at plus or minus 1. So those are the cases. This is when we have to worry about it being reflected, okay? So that's at negative 1 and positive 1. Okay, so this is equal to the absolute value of x squared minus 1 looks like x squared minus 1 when x is greater than or equal to 1 or x is less than or equal to negative 1. This graph is reflected whenever it's between those two things. Okay, so we have to look at the two cases again. So case 1, we're going to say when x squared minus 1 is equal to x. So when x squared minus x minus 1 is equal to 0. So is there such numbers? And my smartboard is freezing. Okay, two numbers such that they can add to be negative 1 and times to be negative 1? No, so we're going to quadratic formula this again. Okay, subbing in, we get 1 plus or minus the square root of 1 minus 4ac, so that's just going to turn into 4, all divided by 2. We get x equals 1 plus or minus the square root of 5 over 2. Gross, hey? Okay, and let's see if that works in our original equation. This is some crazy checking. Okay, does this x squared minus 1 is equal to x is our original equation. So we're going to do 1 plus the square root of 5 over 2 first. 1 plus the square root of 5 over 2 squared minus 1. Is that equal to 1 plus the square root of 5 over 2? Okay, so we get 1 plus 2 root 5. Plus 5 all over 4 minus 1. The absolute value of that is that equal to 1 plus root 5 over 2. Okay, so simplifying this, we would get 1 plus 5 is 6. So we would get 6 plus 2 root 5 minus 4 over 4. Okay, to get a common denominator. So 6 minus 4, now that they have the same denominator, we could just write it like that. 6 minus 4 is 2. So 2 plus 2 root 5 over 4. I can get rid of that absolute value sign because this is all positives that we're dealing with. Is that equal? Yeah, because I could just divide everything here by 2, and I would have the same thing. So even though it was ugly, it totally worked. Okay, let's try the same thing with 1 minus root 5 over 2. Okay. Okay, we have 1 minus root 5 over 2, all squared minus 1. Is that equal to 1 minus root 5 over 2? Okay, squaring this, I get 1 minus 2 root 5 plus root 5 all over 4 minus 4 over 4. I'm going to do it all in one step there. Okay, I have, oh, I can't square root 5 some days. Plus 5. Okay, 1 plus 5 is 6 minus 4 is 2. I have 2 minus 2 root 5 over 4. Okay, is that equal to 1 minus root 5 over 4? Okay, let's think about this for a second. 2 root 5, what does that equal? Is that smaller than 2? And let's see if my calculator will come up here. My computer is very slow. Okay, the square root of 5 times 2. That's 4.47. So I have 2 minus 4.47. Oh dear, how do I go about this one?